Hello and welcome to this video lesson for CPI 111. In this relatively short lesson, we're going to have a quick introduction to the physics system inside GameMaker. We've not used the built-in physics engine for anything really up to this point. We've just sort of faked it in other projects, but if you hook into the physics system in GameMaker, you can have some cool effects. So let's try it out. If you go to the Blackboard site for this lesson, you'll find a starter project. The name of it will vary depending on when it is you're watching this video, but look into the lesson and look for announcements on from the instructor about when and what the name will be for this lesson. All right. In the starter project, we have a collection of sprites. We've got some sprites for our player. It's a cute little character in a costume. We have a couple of sprites that we'll use for collision objects, just to detect against those objects out in the room. We've got a background sprite, and we have a sprite used for tiling. That tiling sprite's already been turned into a tile set. I'm not going to do auto tiling in here, mostly because I ran out of time. We'll just manually place the tiles that we need out into the room. We don't have a room yet, and we don't have any objects yet. So let's get going and make all of that stuff. I want to start with the biggest piece of this. Well, let me step back a little. Let's start by making some objects that we can collide against out into our room. And why don't we go ahead and also, while we're at it, set up a room. So I'm going to create a collision object. So create object. We'll call this one O. Let's see, O collision, and we'll give it the square collision sprite. And so far, this is all the same as what we've done in every assignment up till now, in which we needed to collide against things. But we're going to do something different here, which is to use physics. Boom! Use physics. That's it. You could go and take a look, once you say use physics, at the physics settings. And when you look at the physics settings, there are a collection of properties that can be set in association with this object. How dense the object is, oh gosh, the restitution. I'm not going to go into this in great detail, but for most of these, we're going to leave them as they are, except we're going to set the density down to 0. Okay. Okay. The rest of it's all just going to be the way it is. Why exactly are we setting the density to 0? Well, this is telling GameMaker that this should not react to gravity inside the room. We don't want to have our walls sort of falling down toward the bottom of the room. So by setting it to 0, that will take care of that. Okay? All right. That's all we need to do for that object. While we're at it, let's create a second object. And this will be our, let's call this one O collision hill. And we'll give this that little triangular sprite, and we're going to make it a child of the other collision object. And we'll say uses physics. And here too, we want to make sure that we have the density set down to 0 so it doesn't respond to gravity. Okay, everything else is just the same. Now you might wonder, why am I setting this to be the child of the other object? That's so that when we set up a collision between the player and a solid object, we only have to set up one collision between that parent, and then it will work for the child as well. Okay. So far, kind of the same, except that we're saying use physics and setting the density to 0 so that we don't have to worry about gravity. All right, next thing I'd like to do is let's create a room. And we can call this room whatever we like, I guess. Let's come over here. I'm going to, well, I'll just leave it named room 0. We're not going to have any more than one room. Now here again, because we're now making a physics world in GameMaker rather than a regular non-physics room like we've done before, we need to make some modifications to our room to take care of that. So if you look at the properties of your room over at the left-hand side and expand out the section that says Room Physics, well, we want to enable physics, and then underneath that we can indicate essentially how strong do we want the gravity to be. Right now it's defaulting to 10. I'm going to increase that to 30 just to make the gravity a little stronger. Okay? You can set gravity X as well, which doesn't make a whole lot of sense for what we're going to do. We're going to make a platformer where we want things to fall down towards the bottom of the screen. Okay, so now we have said this is going to be a physics world here. Let's set up our background here. So go to the background layer and expand out your background properties. Let's select our background image and let's tile it horizontally and vertically. And let's see, is there anything else I need to change for that? Nope, that's it. So we've got our background all set up. Let's create, let's create a tile layer. And I'm feeling lazy, so I'll just leave it named as it is, but I'm going to select the tile set that I've created for you in the starter project. And then what I want you to do is spend a few moments going through and laying out the design for a level. Now I want to look, let's check the properties on my room. I might mess with the dimensions of this room a little bit. Let's see. Yeah, let's make the size a little different. I'm going to make it 1280 by 768. You can make this be whatever you like, but this is a pretty good size, I think. Okay. Now, once I've got that set up, I'm happy with the room settings. Let's come back to our tile layer, and let's start to draw out a nice design. So I'm doing this the old school way, which is to lay these out here like so. And you can see, I looked at the grid, we got 64 by 64, which seems to be fine. So let's use that. And just draw out some stuff here. Let's have a floor maybe here going out a couple of spots. And then I'll have something going across here like so. Maybe something over here for a couple of spaces. And let's see. Oh, you know what I'd like to have? I have an angle, so let's do that. Going up like that. And then we'll come over a couple more here. And let's see. Yeah, I think that's probably good enough. Let me just come right over to here. So I'm not spending a ton of time on this. Doesn't really matter for this lesson what your level looks like, but use some creativity and come up with something that you are happy with. Let me quickly fill this in, like so. Okay, maybe while I'm here, I'll create some platforms. Stick one up over here. And maybe one up here. And one sure I'll be able to reach that one, but we'll find out. Okay, that's fine. As long as we're here, let's create as well a new instances layer. And let's rename this one as collision objects. And on this layer, we're going to go back to our resources, grab our collision objects, and then you're going to want to place them out in the room. Now, one nice thing on these collision objects, if I just place one of them here, is that I can resize these like so that I don't have to place a bunch of instances out in the room. Ideally, you want to place as few instances out here as possible for the sake of basically saving your what's the word I'm trying to use? Memory. The fewer instances you have, the faster this thing's going to run. And you don't really need, you're not going to see these at all. So make a few of them and just stretch them out in the room like so. Okay. Alright, I'll skip ahead and have all these in place. Alright, I think I've got them all in place, so you can see what this is going to look like. We may need to modify it a little bit once we get going, but for now this should be okay. Alright, so this is all just set up. Alright, so let's close out our room, go back into our workspace, and let's start to work on our player object. So create an object, call it OPlayer, and let's give it our player idle sprite. And now we are going to be using physics again. So just like we did with the collision objects, we need to select uses physics, and we did the same thing on their room. So for each thing inside this world, we need to make sure to indicate that we're going to be using the physics system so that that will all work. We can check the physics properties for this. We're not going to change any of them. Well, yeah, I'm going to reduce the friction a little bit down to 0.1. You can play around with these values. The main ones are going to be density that you want to play with and friction for now. Okay. All right, then what do we need to do? Well, there's something I want to point out. So if we go and look at our sprites here. In the past, when we have been creating platformers and RPG games, we followed a similar pattern of development in each case, which was we would decide which sprite we wanted to use as the default sprite for an object. So in this case, for example, our default sprite for the player is going to be the idle sprite. Then we would go through and set up the origin point for that sprite and all of the other sprites, and we'd want the origin point to be roughly in the same relative location on each of our sprites so that when we would change from sprite to sprite, it wouldn't jump around in the room. The other thing we were real careful to do is to go into the collision mask for the default sprite and sort of manually adjust that collision mask. But the collision mask in a game that is using the physics engine does not matter. It is not going to be used. So you don't have to mess with the collision mask at all in the way we've done in the past. Instead, when you are setting up a collision mask, you need to use the one that is embedded here inside the physics system. And instead of calling it a collision mask, they call it a collision shape. So go back into the physics properties for our player, and choose Modify Collision Shape. And that will open up a new window. And it's here that you'll set up the default collision mask, collision shape, that you want to be used for this player object. And when you set it up once on the object that you, or the sprite that you're going to start with, the default sprite, whatever you set here will be used for that object regardless of which sprite you associate with it. So let's resize this sucker down a little bit. I want to have a little space on both edges of my character, and I'm going to lower down a little here so it doesn't cover his whole head. Okay? That's it. So we can just set it up right here. You can see him a little bigger here. There he is. I might want to come up a little so it looks like his feet are sort of in the platform. All right. So it's like this bizarro world where we're sort of doing the same stuff that we've always done on other projects, but we're also modifying things. So right now we have a basic object, and if I come out into my room, I'm going to create a new layer just to be organized that is going to hold the player here in the room. So let's call this, rename it, and I'll call it player. And in fact, I have this automated layer that they put in here that I don't really need, so I guess I could delete that. All right, so player layer, I'll select my player, grab them out, and stick them out here. I'll put them way up in the sky here. Now watch quick, okay? Because we're using a physics engine, even though I haven't set up anything in terms of faking my own gravity like I've done on other platformers for our class, this guy will respond to the physics that are in this world and will drop down, and away he goes right out of the room. Okay? So he doesn't yet react to colliding with one of these objects. So just like we did in our platformer project and all of our other projects, we can use a collision event here. I guess I should say on our other platformers, really, we didn't use the collision event. We just detected in a step event if we were going to run into a wall using place meeting, and if we were going to run into a wall, then we move pixel by pixel up until we touch that wall. So we were sort of forming our own fake version of physics. Well, if we use the built-in physics system, we don't have to do that. We can just put in a collision event with the collision object here, and you don't have to put anything in here. Okay. What I will say is detect collisions in the description. Okay. You need to leave some description in here so GameMaker doesn't delete this event thinking that it's not necessary. So now it should detect the collision with that floor object, so our guy should stop. Boom. And there he goes. And you see, kind of cool, he has a tiny little bounce when he hits the floor because it's reacting in a relatively realistic manner, detecting the physics. Okay? Let's go back to our collision object, by the way, and deselect visible. So we don't want to see that out in the room. Same with our child object. All right, let's go back to our player. And let's start setting up our player's movement, which again is going to be similar seeming, but sort of bizarro world different because we need to tie into the physics engine rather than just updating X and Y like we've done previously. So let's do a create event on our player. And in the create event, let us set up a couple of instance variables. We're going to record the player's starting position and storing it to where we're at right now. Okay? And we'll use that later, excuse me, so that when the player drops out of the room, we can just restart the room and position the player back where they were. Not actually even restart the room, just reposition the player back to the beginning. Okay? Now here, the next thing we need to do is something that is specific to physics engines. And what we need to do is tie into our physics engine by setting something called the fixed rotation equal to true. And I might play around with this in a few minutes after we get our player moving to show you the impact this has. But basically it means that because we're in a physics world now, potentially your player could fall over, could sort of land onto the ground and then flip over on his side. And we don't want that to be the case. We want our player to maintain its rotation to what it is when we put the player into the room. So by setting that to fixed, we can prevent our player from rotating. Okay? We'll set up a instance variable for the player's move speed, and we're going to set that to 200. And you think, good lord, that seems very fast. So move speed in this case is not connecting to the idea of the x coordinate and the y coordinate. Rather, this is going to hook into an application of force that we're going to apply on the player in a given direction. With the physics engine, we're moving away from x and y and instead moving into vectors and applying forces on an object, and so it's kind of a different numbering system basically. So we'll set our move speed to 200, but we do want to and need to connect that force application to an actual movement of pixels in the room. And so we're going to also have an instance variable that I'm going to call max x speed, and I'm going to set that to 3. We will use this as a way to cap how quickly an object will be able to move across the room. Once we begin applying a force to our player in a given direction, and if we continue to apply a force, under the idea of physics, our player will just keep speeding up, speeding up, speeding up, speeding up, but we want to cap that speed. And we're going to use this max x speed equals 3 to cap that speed. And we're using a numbering system here that's more relatable to what we've done in the past. This 3 is going to represent how many pixels per step the player can move horizontally, and we're going to cap that at 3. We can play around with that a little bit as well. We're going to have another instance variable here called jumping that we'll use to determine if the player is jumping or not, similar to what we've done in our platformer. And we're going to have another instance variable called jump force, and this is going to be basically how much force we want to apply to the player upward when they jump. We did the same thing in our platformer. There I think we had something called VSP, and I don't remember what it was, something like -7. Again, there we were talking about pixels per step that we wanted to allow our player to move. Here we're connecting to a different system, so it's going to be a very different value. We're going to say -170. Now you can adjust this as needed. Bigger equals higher jumps. Okay? Or I guess I probably should say smaller. A larger negative number means a higher jump. So let's say larger negative number equals higher jumps. Okay. And last but not least, we're going to set the image speed to something small. We want our player to initially just be standing out in the room and slowly sort of rotating through the images for its idle animation. If you look at our idle sprite, it's only 2 frames, and if I play this thing, the guy looks like he's gone insane. Okay, so we're slowing that way down so that the animation looks a little bit better. Alright, so that's all the setup that we need for our player. Now let's go into the step event, and this is going to function in some ways a lot like our platformer we made earlier, and in other ways a bit differently. So let's do movements. All right. First thing we want to do in here is, oh, this is going to look very familiar. We want to detect key inputs. So it's coming straight up our platformer. Detect input, and so we're going to have a key left, and the key left is going to be equal to keyboard check, and I'm going to use ORD A, or if I can type well, keyboard check VK left. I hope this looks familiar because this is exactly the same code we used in our platformer. I'm going to paste in a few things here because this is all going to be very similar. We're going to have a key right equals whatever key we want to use for the right, which is going to be D, or the right arrow. And then we're going to have a key jump, which is going to be a little bit different. We want to do keyboard check pressed in this case, and I'll use the W key or the up arrow. Okay, all exactly the same as what we did in our platformer. Now we'll calculate movement. We're going to put in a local variable I'll call move, and I'm going to set this to, oh, I almost should make this a quiz. Key right minus key left. Fine. Now we can actually start moving. Walk. So we're going to say, oh, well, this is where it's going to get different. Okay, so up to this point, all of the detection that we're doing and then the checking if we're moving or not is the same as it was in our platformer. But now to actually make the guy move, our little player move, is going to be different. Before, one of the things we were doing is we would update our own custom vertical speed and horizontal speed based on a collection of things we wanted happening in the room, and then we would finally update the player's X and Y position. Here we're going to use a physics function called physics apply force. And for physics apply force, this is going to continuously apply a force to an object basically every time this runs. Okay, so we need to say where in the room do we want to apply the force. Well, we're going to apply the force right where we're at. Then we need to say what is the force we want applied on the object's X. So horizontally, how much force do we want to apply? And the amount of force we're going to apply is move, okay, that local variable that we set, times move speed. Okay, so this move is either going to be 0, -1, or 1, and then we're going to multiply that by our move speed, which we set in our create event as 200. Okay, so it's either going to be 0, 200, or -200 is how much force we're going to apply on the X. Then we need to say how much force do we want to apply on the Y, and we're going to set that to a minus value, meaning we're going to apply a slight force upward on this object and a much larger force either left or right. So you might ask, why are we applying the slight force upward? Well, with the physics engine, the way we've set it up is we're constantly pulling the player down toward the bottom. And so by giving a slight upward impulse, it's going to allow us to be able to move without sort of being stuck against the floor. All right? So that's walking. We also want to jump. And so if we're jumping, we'll say if key jump, okay, meaning if they have pressed the key jump key, then we want to do some stuff. Well, we want to check first to see if they are on the floor, just like we did in the platformer. So remember how we did that? We used place, meeting. We checked our current X, we checked our Y position +1, and then we have to say what is it we're checking against. We're checking against O collision. Okay, so this is how we check to see if we're on the floor. And if so, then we're able to jump. We're going to update our jumping variable to true, and I'll tell you why we're using this in a second. We're going to set an alarm, alarm 0, for 1 step, and we are going to apply a force. Just like we did for running, but now we're going to apply the force right where we're at. On the X, we're not going to apply any force at all, but for the Y, we're going to apply whatever we stored in our jump force. Okay. Let's just start it with that for now. Okay. So if they're on the ground, we're going to let them jump. We're going to set this instance variable jumping to true. We're going to set an alarm, and then we're going to apply force. So why in the world are we setting an alarm? That seems a little nutty. Well, the reason we're going to set this alarm is that it's going to allow us to implement a double jump, so that if the player jumps and then they quickly hit the jump key again, we can apply additional force to allow them, in a very unrealistic way, to jump a little bit higher. Okay, so let's set that up. Second jump. And we're going to check if jumping equals, or actually I just say if jumping, so jumping's true, which we've just set true in our original jump, so this is only going to work if we're in the middle of a jump. Okay, if we're jumping and our alarm has gone off, then we'll jump. I'm going to steal this code right here, place it in here, and I'm going to set jumping equal to false. Okay. So let's think about how this works. So if the player's on the ground, we're going to allow them to jump, so we apply a force. We also set a variable called jumping to true, and we set an alarm for 1 step. Then we're going to check if they're in the middle of a jump, which we know by if jumping is true, and our alarm goes off, we're going to allow them to apply another force. So the idea is, imagine the player presses the jump key and they immediately, almost immediately, press that jump key again. We're going to allow them to apply an additional force. It's pretty cool, right? Now we don't have an alarm yet. We'll have to make sure to set this alarm. In fact, why don't we do that now? Okay, let's go in and set an alarm, alarm 0. And we don't have to say anything in here. We're just using it as a timer, but we need to leave some sort of comment in so that GameMaker doesn't get rid of it. So we'll call this the double jump alarm. All right, back into our step event. So this should take care of all of our movement, but it doesn't take care of any of the updated images for our character sprites. So let's see what we've got. He comes down. You can see he's in the idle animation here. I can move left. I can move right. Ah, when he falls out of the room, he disappears because we haven't set that up yet. I'll have to set that up. But he should also be able to jump, so let's check that real quick. No, it's not letting him jump, so we'll have to play around a little bit. Something, oh, well, something's amiss on our jumping, so that's fine. We'll figure out what it is and we'll get it fixed.